Hello AP Statistics students. In this video, we are taking a look at another free response question. This one is number 6 from 2016. So this is the infamous number 6. All right, it's the free response question. It's a little bit harder, a little bit longer, and can sometimes ask you to think about statistics in a new way that you haven't explicitly been taught. All right, they recommend 25 minutes. Whew. 25 minutes. Let's see if Bolt can do this faster than 25 minutes, all right? I hope so. So, let's see. What is our scenario here? A newspaper company in Germany reported that the more semesters needed to complete an academic program at the university, the greater the starting salary in the first year of a job. The report was based on a study that used a random sample of 24 people who had recently completed an academic program. Information was collected on the number of semesters each person in the sample needed to complete the program. All right, that's our explanatory variable, right? Number of semesters. And the starting salary. That's our response variable. In thousands of euros for the first year of a job. The data are shown in the scatter plot below. So first question, letter A. Does the scatter plot support the newspaper report about number of semesters and starting salary? Justify your answer. All right, so the idea was, let's see. Where's the actual report here? Yeah, that's the very first sentence. All right, the number of semesters needed to complete an academic program at the university. So the more semesters it takes, the greater the starting salary of the job. Does this support that? And well, it does, right? As the number of semesters goes up, the starting salary goes up. There is a positive association, a positive correlation here. So yes, the scatter plot does support the conclusion that more semesters to complete a program correlates to a higher starting salary because, all right, here's the main thing. Most of that was all just context. Why does it support this? Well, because there's a positive association. Because the scatter plot has a positive association between these two variables. Yeah, it's going up and to the right, correct? It is. It does have a positive correlation. The regression line would have a positive slope. Something like that is what you need to say. Using the word correlation and association are great. You might put the word weak in there, though. It's not a very strong correlation, right? It's more like it's weak and positive, but all that is pretty good. But it is still a positive association, positive linear association. All right, the table below shows the computer output from a linear regression analysis on the data. All right, so here's our computer printout. Letter B asks, identify the slope of the least squares regression line and interpret the slope in context. All right, well, so we definitely need to be able to know which one the slope is. Right here is our slope. So let's interpret that number. So the slope is 1.1594, which means for every, remember there's a 1 under the slope, one semester increase in a college program, we expect an increase of 1.1594. I'm guessing that's not in just straight up euros, right? Is it in thousands? in thousands of euros. Yeah, in thousands of euros. 1.1594 thousand euros in predicted. This is actually a very important word here. Predicted starting salary. Because the least squares regression line, the regression line is the predicted starting salary. And I looked at the rubric, and you have to have some sort of way of saying it's the predicted amount that's going up, not the actual amount, because the actual amount fluctuates. All right, there's quite a bit of variability. You needed to have the word predicted in there somehow. So far, so good. I hope that's not too bad. Let's keep going. I think now it's going to get a little interesting. So an independent researcher received the data from the newspaper and conducted a new analysis by separating the data into 3 groups based on the major of each person. A revised scatter plot identifying the major of each person is shown below. All right, so we got circles, little diamonds, and the X's now for business, physics, and chemistry. So based on the people in the sample, describe the association between starting salary and number of semesters for the business majors. All right, so which ones are the business majors? So here are my business majors, but that are these people right here. We'll take a look at that. That's not a positive association, right? That's actually now a negative association, and it's quite strong negative association, all right? So for business majors, there is a strong negative and linear association, all right, between number of semesters for a degree and the starting salary. That's, well, for all of you heading to college, that's not very comforting now, is it? There's a negative association between those two. Good luck out there. I looked at the rubric, and they added one more contextual sentence to this idea. They added this means that the longer a program is, the lower the starting salary was. All right. I don't know if that second contextual sentence is actually necessary. The main stats here is that it's a strong negative linear association between the two variables. So make sure you do add the context, the number of semesters and the starting salary. Those are our two variables. All right, D. Based on the people in the sample, compare the median starting salaries for the 3 majors. All right, that would have been much easier to do if we had the data, but we don't, and we can't cry about it. So let's find the median of these salaries. So let's start with the business. So the median is the middle one. And so let's see, there's 1, 2, 3, 4, 5, 6, 7, 8 dots. So I need the middle fourth for starting salaries. I'm only looking at the Y. So when I count up 1, 2, 3, 4, the 4th and 5th dot is between these two. That's the middle. I'm counting vertically only. I'm not thinking side to side. I'm just counting vertically. So the lowest, the next lowest, the next lowest, the next lowest. Right there is the middle. So for business majors, it's right around what, 37, 38? Somewhere in there. All right, you don't have to be super accurate, just in the right ballpark here. So again, I'm going to count up for the middle for now the physics majors. 1, 2, 3, 4, and then so it's between these two, right? So that's almost 50, but not quite, maybe like 48, 49. And now for the chemistry majors, 1, 2, 3, 4. It's between these two, isn't it? Right there, 4 on the top, 4 on the bottom, and that's basically exactly 55. So it wants us to compare these three. So we would say that business majors have the lowest median at around 38. Then physics majors at around 49-ish thousand. And then chemistry has the highest median starting salary at about 55,000. So I got to put that into words. So business majors have the lowest median starting salary at approximately 38,000 euros. Then comes physics with a median of, what did I say, like 49,000 euros. And chemistry majors had the highest median starting salary context with, what was it? I forgot. 55,000 euros. All right, we're comparing the three medians there. Hopefully that kind of makes some sense. Again, something kind of new. We haven't actually done something exactly like that before, but you have the tools to do it, I hope. All right, E, based on the analysis conducted by the independent researcher, how could the newspaper report be modified to give a better description of the relationship between the number of semesters and the starting salary for the people in the sample? So if we really wanted to tell the truth, if we wanted to do good statistics and not the BS, what would we say here? Well, we want to say both things, all right? Both of these are true facts. This one, that yes, the more semesters to complete the program correlates to a higher starting salary. That's not wrong. But we also have to tell the story of this, that within each major, there is a negative linear association as well. So we're going to try to sandwich both of those ideas together. So, looking at each major as a whole, it is true that longer programs do associate with higher starting salaries. Okay. However, within each program or major, longer programs are negatively associated with starting salary. So longer programs within each major, kind of got a run-on sentence here, but bear with me. All right, I could have started a new sentence. With longer programs within each major, will usually have lower starting salaries. So I kind of tried to share both sides of the story there. Now, that's actually a really big statistical concept. It's called Simpson's paradox, where if you look at the data as a whole, okay, if you just look at this whole piece of data as a whole, you may not see smaller trends. It looks positively correlated. But if you look at smaller groups, you will see something different happen. That actually happened with to keep going here past my time limit. This actually happened with coronavirus data. For a while at the beginning, the entire nation's numbers were on a decline. But that was not telling the whole story, because overall numbers were declining because huge areas like New York were declining. but smaller communities were actually increasing in numbers. But those increases weren't seen because New York's numbers were so massive and they were decreasing a lot, it overshadowed the increases in smaller communities. So that's a statistical idea called Simpson's paradox, which not part of the course. This is true. And you didn't need to know that vocabulary to do this question, but that's what it was talking about. So it's making you do new statistics that you haven't seen before, but still using the tools that you do have. All right, that was number 6 from 2016, everybody. I hope that made some sense.